All right, we are going to determine the location of a terminal point given the sines of the trigonometric value. Here we're doing the sine and the tangent. So we're going to start off and say, okay, sine is opposite over hypotenuse, tangent is opposite over adjacent. So we want to think about the sines when we're in each quadrant. So if I think about this and I have this, we know that the opposite and the adjacent and the tangent are positive in quadrant 1. In quadrant 2, the opposite side is positive and the tangent is always, or the hypotenuse is always positive, but the adjacent side is going to be negative. If I do quadrant 3, the adjacent side is negative, the opposite side is negative, and the hypotenuse is always going to be positive. And if I do quadrant 4, my adjacent side is positive, but my opposite side is negative, and my hypotenuse is positive. So if I'm thinking about the sine being less than 0, I'm going to have a negative over a positive. So my opposite side is going to have to be negative. Negative over a positive, my hypotenuse is always positive, and so in quadrant 3 and quadrant 4, I have a sine that is negative. If I'm doing the tangent is positive, tangent is opposite over adjacent, so I'd either have to have both positives or both negatives. So my opposite over adjacent is both going to be positive in quadrant 1, and then it's going to be in quadrant 3 because I'm going to have a negative over a negative. Negative over a negative is going to be positive. So where is my sine negative and my tangent positive? In quadrant 3, if I check out my sides. Then, on the second one, I'm doing sine, which is opposite over hypotenuse again, and I'm doing cosine. Cosine is adjacent over hypotenuse. So again, we want the sine is less than 0. We did that on the previous one. Quadrant 3, and quadrant 4 is where my sine was negative. I want my cosine to be negative. So since my hypotenuse is always positive, I want the ones with the adjacent side that's negative. My adjacent side that's negative is going to be in quadrant 2 and in quadrant 3. And so again, we got quadrant 3, that the sine is negative and the cosine is also negative. And so both of those on A and B ended up giving me quadrant 3. Now you might want to just start keeping a big list. Sine is positive in which quadrants, negative in which quadrants. Cosine's positive in which ones, negative. And just start making a list so that you don't have to check every time, but otherwise we're going to check. So I will go ahead here and move the board, and we will look at number 2 and 3 doing the same kind of thing. So again, if I think about my quadrants, in quadrant 1, everything is positive. Quadrant 2, my adjacent is negative, but my opposite is positive. Quadrant 3, my opposite is negative. And quadrant 4, my opposite is negative. And of course, my hypotenuse is always positive. So I want to first of all do cosine and sine. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. I want my cosine to be positive, which means I'd have to have a positive over a positive. And so my hypotenuse is always positive. That means I want my adjacent to always be positive, which means here's my adjacent side, so quadrant 1 and quadrant 4. I want my sine to be positive, so I want my opposite to be positive over my hypotenuse, which is always positive. So I'm looking for the opposite side to be positive. My opposite side is positive in quadrant 1 and quadrant 2. So where does that match up? Quadrant 1. would be where I would match up. Then I am going to do tangent and cosine. So tangent, opposite over adjacent. Cosine is adjacent over hypotenuse. I want my tangent to be negative. So if I'm going to have a negative, I have to have one positive and one negative. So if my opposite side is positive, my adjacent side would have to be negative. That would be over here in quadrant 2. If I'm going to have my opposite side negative, then I'd have to have my adjacent side to be positive. So negative and a positive, that would be over there in quadrant 4. Cosine, I want my cosine to be positive. So I want my adjacent to be positive because my hypotenuse is always positive. My adjacent side is positive here in quadrant 1 and quadrant 4. And so in this case, quadrant 4 is where my tangent is negative, but my cosine is positive. And 3, I'm doing the cosecant. The cosecant is the inverse of the sine, so I'd have my hypotenuse over my opposite, and then of course my cosine, my adjacent over my hypotenuse. So I want my cosecant to be negative. This is always positive, so I need my opposite side to be negative. My opposite side is negative down here in quadrant 3 and quadrant 4. By the way, since the sine and the cosecant are inverses, then they're going to be positive and negative in the same quadrants. So if you're making a list, you could put sine or cosecant positive in quadrant 1 and 2, negative in quadrant 3 and 4. Cosine is inverse of the secant, so the cosine and the secant will have the same ones. Tangent and cotangents will have the same ones. If I do my cosine, my adjacent over my hypotenuse, I want my cosine to be positive, so I need my adjacent side to be positive. Since my hypotenuse is already positive, my adjacent side is positive in quadrant 1 and quadrant 4. So on this one, they have quadrant 4 in common for my answer. And then we got sine and cotangent. Sine is opposite over hypotenuse. Cotangent is adjacent over opposite. It's the inverse of the tangent. So I want my sine to be negative. I know my hypotenuse is positive, so my opposite side has to be negative. Which ones have opposite sides that are negative? Quadrant 3 and 4. Cotangent. We want the cotangent to be negative. So either we have to have a negative over a positive or a positive over a negative. So my adjacent side, we'd have a negative over a positive in quadrant 2. And then a positive over a negative. Positive. My adjacent side is positive. Positive over a negative in quadrant 4. So adjacent is positive, my opposite is negative, that makes that negative. So what they both have in common, quadrant 4. So kind of want to have this, and again, if you need to label, we have the adjacent side is my x-axis, my opposite side is the y direction, of course my hypotenuse is the hypotenuse of my right triangle. And so when I'm looking there, I might want to figure out, well, what signs do I have to be negative or positive? Keeping in mind the hypotenuse is always positive. Next one, say, finding the value of a trigonometric function given information about an angle. This is problem type 1. So what we're doing is we're thinking about our graph, and that this is my x direction and this is my y direction. So if I'm doing -2, -3, I would be over here in quadrant 3. Then I'm going to use my Pythagorean theorem to find out what my hypotenuse is. I know that a squared plus b squared equals my hypotenuse squared or my c squared, right? So here I would get 4 plus 9, which is 13. And so I'm going to have the square root of 13, keeping in mind my hypotenuse is always a positive number, square root of 13 then. Then I'm going to do my functions that they give me. Cosine is the adjacent over the hypotenuse. The secant would be the inverse of that, hypotenuse over adjacent. Cotangent is going to be the adjacent over the opposite, the inverse of my tangent. And so now I can look at my drawing here and say, okay, the adjacent side is -2, the hypotenuse is the square root of 13. So -2 over the square root of 13, of course, has to be rationalized. We can't have the square root in the bottom of our fraction. So we multiply by the square root of 13, and so we get -2 square root of 13 over 13, because we know that if we take the square root of 13 times the square root of 13, it's the square root of 169, which is a perfect square, 13. Because when we multiply two square roots by each other, it rationalizes it and gets rid of the square root. Secant. Secant is the hypotenuse, which is the square root of 13, over the adjacent, which is -2. Of course, we want the negative out in front, so negative square root of 13 over 2 going to end up being our answer. And cotangent, the adjacent side, which is -2, over the opposite side, which is -3. Negative over a negative gives me positive, so 2/3 would be my solution. So we'll go ahead and take a look at number 5 and number 6 here. Number 5, let 6, -5 be a point on the terminal side of theta. So 6 in my x direction, -5 in my y direction. And then, of course, I want to find my hypotenuse using my Pythagorean Theorem. So 6 squared plus -5 squared equals c squared. So 36 plus 25 gives me 61. Then I have to take the square root. So the square root of 61 would be the value of my hypotenuse. And this time we want to do cosine, cosecant, and tangent. So cosine is adjacent over hypotenuse. Cosecant is the inverse of my sine. So my hypotenuse over my opposite. Tangent, opposite over adjacent. And so my adjacent side is 6 over my hypotenuse, square root of 61. Again, I have to rationalize the denominator. So I'm going to get 6 square root of 61 over 61. Can't simplify. That's going to be my first answer. Cosecant says we're going to do the hypotenuse over the opposite. So we're going to have the square root of 61 over -5. And again, since that's negative, we'll put the negative out in front. So negative square root of 61 over 5. And then for my tangent, I'm going to do the opposite over the adjacent. So -5 over 6. So -5, 6. And then number 6, same kind of thing. Draw my reference angle here. I'm going to go -2 in the x direction, 7 in the y direction. So -2, 7. Finding my hypotenuse, -2 squared plus 7 squared equals c squared. So 4 plus 49 would be 53. And then I have to take my square root. So square root of 53 is going to be the measure for my hypotenuse. And this one, we are going to do the sine, which is opposite over hypotenuse, the cosecant, which is that inverse of that, so hypotenuse over opposite, cotangent, which is the inverse of the tangent, so adjacent over opposite. So sine, my opposite over my hypotenuse. So I'm going to get 7 over the square root of 53, which we rationalize. So I get 7 square root of 53 over 53. Cosecant, we are going to do the hypotenuse, which is the square root of 53, over the 7. The opposite, square root of 53 over 7. Not much we can do with that one. That's just going to be my answer. And then the cotangent, I'm going to do the adjacent over the opposite. So negative 2 over 7. So negative 2 seconds. So just finding these by drawing our reference triangle, doing the Pythagorean Theorem in order to find the value of our hypotenuse, and then plugging them into the formulas, if you want to call them formulas, for sine, cosine, tangent, cosecant, secant, or cosecant. The next ones we are sketching the graph of the sine or cosine function, and before we actually do the problem, you want to have what a normal sine or cosine graph without any shifts look like. So if I'm doing the sine curve, the sine curve has a period of 2 pi. It starts at 0 and one cycle goes 2 pi. On the sine curve, at the beginning and the end, you are at 0, and halfway between there, you're also at 0. For the sine function, it is going to go up the amplitude and down the amplitude halfway between. So this would be pi over 2, and this would be at 3 pi over 2. And so your sine curve looks something sort of like this, only it just keeps going and going and going and going. So if you're thinking about your table, you have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for a regular sine curve with no shifts, you have 0 and 0 and 0. 0 at the beginning, the middle, and the end. Here you're going to go up your amplitude, whatever your amplitude might be. Here you're going to do the opposite of your amplitude, whatever the amplitude might be. And we'll talk about the amplitude when we get to graphing this function right here. Cosine function has a period of 2 pi. So 0 to 2 pi is one complete cycle. Again, we're going to have our same markers where we're splitting things in half. So for the cosine function, you're going to start up at the amplitude, you're going to end at the amplitude. And halfway between, you're going to do negative the amplitude, whatever it might be. Here you're going to cross the x-axis because you're going to look something like that when you do your cosine curve. So for your cosine curve, you have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Here you're going to be at your amplitude. Here you're going to be at your amplitude. Here you'll be at the opposite of your amplitude, and 0 and 0 between those things. So I scribbled all over. You probably want to make your notes not quite in the middle of where we're going to do number 7, but I am now going to do number 7. And so I'm going to move the board and erase that so I have some room to write. So number 7 says 3/2 sine of x plus pi over 3. This value here is going to be your amplitude. Now normally when you do the amplitude, they'll call this A, and the amplitude they always give is a positive number, but depending if that's positive or negative, it tells you if you're going to go up first or down first. Since this is positive, I'm going to go up to 3/2 first. If it was negative, I would go down to 3/2 when I go down. But keeping in mind my normal sine curve, 0, 0, pi over 2 is at your amplitude, pi is at 0, 3 pi over 2 is at your amplitude, actually at your opposite your amplitude. Let me write that. minus your amplitude, and 2 pi is at 0. Now this is going to have a shift to it. So what you're going to do for the shift is you're going to set this equal to each of your normal x values. So I'm going to say x plus pi over 3 equals 0 and solve it. X plus pi over 3 equals pi over 2 and solve it. X plus pi over 3 equals pi and solve it. X plus pi over 3 equals 2 pi. Not 2 pi, 3 pi over 2. 3 pi over 2 and solve it. And x plus pi over 3 equals 2 pi. So I set them each equal to each of my normal x values. So if I'm going to solve, I'm going to subtract pi over 3, which gives me negative pi over 3. Here I'm going to subtract pi over 3. I'd have to find my common denominator, which is 6. So I'd have 3 pi over 6 minus 2 pi over 6, which gives me pi over 6. Here I'm going to subtract my pi over 3. So I'm going to have 3 pi over 3 minus pi over 3, which is 2 pi over 3. Fun with fractions. Here I'm going to subtract my pi over 3. So common denominator would be 6. 2 goes into 6 3 times, so that would be 9. 3 goes into 6 2 times, so I get 7 pi over 6. And then 2 pi minus my pi over 3 means I'd have 6 pi over 3 minus pi over 3, which is 5 pi over 3. So now these are going to be my new x values, but the values for my other things are going to stay the same. So at pi over 3, this is at 1, 2, 3, 4, 5, 6. So each of those are pi over 6. So pi over 3 would be 2 pi over 6. I'm going to be at 0. At pi over, oops, wait a minute, that was supposed to be negative. 0 minus pi over 3, let me fix that. Negative pi over 3, I should be at 0. So I should be back here. Okay, pi over 6 would be 1 mark over. I'm going to be up to my amplitude, which is 3/2, so up to 1.5. 2 pi over 3 would be 4 pi over 6. 1, 2, 3, 4. I'm going to be at 0. 0 in the middle. Now the next one I'm going to go down to my amplitude at 7 pi over 6. 1, 2, 3, 4, 5, 6, 7. I'm going to go down to negative 1.5. Since my amplitude there is 3/2, I'm going to do negative 3/2 there. And then at 5 pi over 3, which would be 10 pi over 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm back at 0. So my sine curve, one cycle, is going to look something like that. Now you're going to put those 5 points on your graph, and then it's going to complete your graph for you. Now if you want, you can use the plot point tool and type in your ordered pairs instead of having to figure out where on the graph it goes. It's probably easier for you to do that. Since I don't have a plot point tool, I had to figure out where I was at as far as each of these to get to pi is 1, 2, 3, 4, 5, 6. So each line is pi over 6, and I figured it out from there. So, number 8, we're going to do a cosine graph. So I got to think about my normal table for cosine. Cosine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. For cosine, we start at the amplitude, we end at the amplitude, and we go negative the amplitude in the middle. At pi and 3 pi over 2, we're at 0, partway in between. So we want to do the same kind of thing. Here my amplitude is going to be 3. So I'm going to have 3, negative 3, and 3. I got to figure out my shift. So I'm going to do x minus 2 pi over 3 equals 0. x minus 2 pi over 3 equals pi over 2. X minus 2 pi over 3 equals pi. X minus 2 pi over 3 equals 3 pi over 2. And x minus 2 pi over 3 equals 2 pi. So on each of these, I'm going to add 2 pi over 3. I'm just going to put it down there. So 0 plus 2 pi over 3 would be 2 pi over 3. Here I'd have to find my common denominator, so it's going to be over 6. 2 goes into 6 3 times. 3 goes in there 2 times 2 is 4, so I get 7 pi over 6. Here I'm going to have 3 pi over 3 plus 2 pi over 3, which is 5 pi over 3. Here again I'm going to go over 6. 2 goes in there 3 times, so 9. 3 goes in there 2 times, so 4. 9 plus 4 gives me 13 pi over 6. And then here I'm going to go over 3, so 6 pi over 3 plus 2 pi over 3 is 8 pi over 3. Again, if I look at this one, there are 1, 2, 3, 4, 5, 6. So each of these is pi over 6. If it's over 3, I have to do double that. So 2 pi over 3 would be 4 pi over 6. 1, 2, 3, 4. Since this is cosine, I'm going to go up to my amplitude first. So I'm going to go up to 3. 7 pi over 6. 1, 2, 3, 4, 5, 6, 7. That's going to cross right at 0 because our next point is at 0. Now we're going to go to negative 3 at 5 pi over 3, which would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes all the way down to negative 3 for our next point. The next one's going to be at 0. So 13 pi over 6, this was at 10. 11, 12, 13. And then the next one's going to go up to our amplitude at 3. 8 pi over 3 would be 16. So 13, 14, 15, 16 goes back up here. And our cosine curve, and when you hit it, it's going to do a lot of cycles, but that'll be one cycle of our cosine curve. So starts at the top, my amplitude down to the bottom is in the middle, halfway between, we cross at 0, and so our table looks something sort of like that. Number 9, we're back to our sine curve. So for our sine curve, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Our sine curve, 0, 0, and 0. Then here we're at our amplitude. Here we're at our negative, our amplitude. And like I said, if this happens to be a negative, you'll do the negative first and then the positive. Those two things will switch around. Since it's positive, we're going to do the positive first and the negative second. So, doing our shift. X minus pi over 4 is going to equal 0. Equal pi over 2. Equal pi. Equal 3 pi over 2. And equal 2 pi. So in all of these, we have to add our pi over 4. I don't know where I was looking there. So here I'm just going to get pi over 4. Here I am going to have 4 for my common denominator, so I'd have 2 pi over 4 plus 1 pi over 4, which is 3 pi over 4, right? 1/2 plus 1/4 is 3/4. Here I'm going to have 4 pi over 4 plus pi over 4, which is 5 pi over 4. Here, 6 pi over 4 plus pi over 4 is 7 pi over 4. And 8 pi over 4 plus pi over 4 is 9 pi over 4. So, this one, notice I've got 1, 2, 3, 4. Each of my lines is pi over 4. At pi over 4, we're starting at 0 since we're doing the sine curve. At 3 pi over 4, 1, 2, 3, we're going up to our amplitude, which is 2.5. At 5 pi over 4, that was at 3, 4, 5, we're at 0 again. 0's our third one. 7 pi over 4, we're down to our amplitude, so down to negative 2.5. And then at 9, we're back to 0. So sine curve, 0 at the beginning, 0 in the middle, 0 at the end. If our amplitude is positive, we go up first. If it would be negative, we'd go down first. And so when we connect our dots, our sine curve is going to look something sort of like that. 10, 11, and 12, we are going to graph the sine or the cosine function again, problem type 2. This time we're going to have a change in our period. It's not going to have a shift to it. And so we're going to do pretty much the exact same thing we did on the previous problems. This one's starting with the cosine curve. So if I go with my normal table for cosine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since it's a cosine curve, normally we do the amplitude at the beginning and the end, and we do opposite the amplitude in the middle, 0 and 0 halfway between those. But notice this one starts off with a negative 3. So we're going to do the negative 3 at the beginning and the end. The opposite of negative 3 means it's going to go to positive 3 there in the middle. Now this time we're going to take what's in our parentheses here, set them equal to each of our x values, and solve. So if I have 1/2 x is going to equal 0, 1/2 x is going to equal pi over 2, 1/2 x is going to equal pi, 1/2 x is going to equal 3 pi over 2, and 1/2 x is going to equal 2 pi. So if I'm going to solve each of these for x, I'm going to multiply by 2. Right, cancel out my fractions. So times 2 on each of these. So I'm going to get 0 times 2, which is 0. Here the 2's cancel out, so I get pi. Here I'm just going to get 2 pi. Here I'm going to cancel out my 2's and get 3 pi. Here I'm going to get 4 pi. So now these are all my new starting values from my table. And so I'm going to have 0, pi, 2 pi, 3 pi, and 4 pi. So 0 is going to go to negative 3 since I'm doing the cosine function. My amplitude technically is 3, but since it's negative, I'm going to go down first. Pi is going to be at 0. 2 pi is going to go up to positive 3. 3 pi is going to be at 0, and 4 pi is going to go down to negative 3. So, really stretched out my cosine curve. Instead of having a period of 2 pi, I ended up having a period of 4 pi for one complete cycle. Number 11, same kind of thing. I'm doing my sine curve first. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since it's a sine curve, 0, 0, 0, my amplitude, and minus my amplitude. So this time my amplitude is going to be at 3/2, so this would be at negative 3/2. So figuring out my shift. 2x would equal 0. 2x is going to equal pi over 2. 2x is going to equal pi. 2x is going to equal 3 pi over 2, and 2x is going to equal 2 pi. So, if I'm getting rid of my coefficient, I'm dividing by 2, but since I'm working with fractions, dividing by 2 is multiplying by the reciprocal of 2, 1/2. I'm going to times by 1/2 to cancel out my fractions. So every one of these is going to get multiplied by 1/2. So 0 times 1/2 is 0. Pi over 2 times 1/2 would be pi over 4. Pi times 1/2 would be pi over 2. 3 pi over 2 times 1/2 is 3 pi over 4. And 2 pi, my 2's are going to cancel out, just gives me pi. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. So this is 1, 2, 3, 4, so those are in fourths. 0, 0 is my first point. Pi over 4 is at my amplitude of 3/2, so pi over 4 would be up at 1.5 right there. Pi over 2 would be 2 pi over 4, or halfway, going to be at 0. 3 pi over 4 is going to be at negative 1.5. And then at pi, we're going to be at 0. So this time my period is only pi instead of 2 pi, and my sine curve got smushed away together. And again, on Alex, it'll just keep going up, down, because my sine curve really continues on and on. We're just graphing one cycle of our curve. Number 12, we are going to do our cosine function. So if we're going to do our cosine function, 0, pi over 2, pi, 3 pi over 2, and 2 pi. For our cosine, we have our amplitude, then we have 0, then we have the opposite of our amplitude, then we have 0, and then we have our amplitude, which in this case is positive 3. So 3, 3, negative 3 is going to be in the middle. So we are going to say 3/2 x equals 0, 3/2 x equals pi over 2, 3/2 x equals pi, 3/2 x equals 3 pi over 2, and 3/2 x equals 2 pi. So again, I'm dividing by 3/2, which is going to be multiplying by the reciprocal times 2/3 then. And so every one of these I'm going to multiply by 2/3. 2/3. Keep in mind on one thing. So 0 times 2/3 is 0. Here the 2's cancel out, so pi over 3. Here I'm going to get 2 pi over 3. Here's the 2 cancel out, the 3's cancel out, I just get pi, and there I'm going to get 4 pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So this stays at 0, this is now pi over 3, this is 2 pi over 3, this would be pi, and this would be 4 pi over 3. I probably should have done this when we did 7, 8, and 9, so that you could see where I was going. So 0 is going to be at 3. Pi over 3, we are in sixths again. 1, 2, 3, 4, 5, 6. So 2 pi over 6 would be at 0. 2 pi over 3 would be 4 pi over 6. We're going to be down to negative 3. 1, 2, 3, 4. Pi, which would be pi, 0. And then 4 pi over 3 would be 8 pi over 6. So 6, 7, 8 is going to be up to 3. And so our graph is going to look something like that. So when there's a number in front of the x, it is going to change what the period is. The period normally is 2 pi, but it's either going to smush it together or stretch it out farther. Again, the number in front is your amplitude. Normal amplitude is positive numbers because I use the absolute value to give my amplitude. My amplitude, by the way, is how high and low I'm going. I'm going 3 above and 3 below. If it's negative, I go down first instead of up first, so it would start down here at -3 and then go up. And so it does the opposite of if you had a positive or a negative. Last 3 on this page, again, we're doing the sine or cosine function problem type 3, where we have both a change in our period and a shift to our graph. But again, basically we're doing the exact same thing we did on problem type 1 and problem type 2. I'm going to start with my cosine function. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since it's my cosine function, I have my amplitude up if it's positive, and then negative in the middle, and 0 and 0. So keep in mind that if my amplitude or my number in front of here is negative, then the negatives go first and then the positives are in the middle. In this case, my amplitude is a positive 3/2, so I can put those in there. I got to figure out what my phase shift and my period are going to turn out to be by setting what's in the parentheses equal to each of one of these values. So I'm going to say 2/3 x minus pi over 3 equals 0. 2/3 x minus pi over 3 equals pi over 2. 2/3 x minus pi over 3 equals pi. 2/3 x minus pi over 3 equals 3 pi over 2. And 2/3 x minus pi over 3 equals 2 pi. So I'm going to solve each one of these. First thing I'm going to do is add my pi over 3. Since I don't have a whole lot of writing room, I'm not going to do all of it on the board, but 0 plus pi over 3 is pi over 3. Here, I'm going to have it over 6, so 3 pi over 6 plus 2 pi over 6 is going to give me 5 pi over 6. If you're bad with fractions, eliminate the pi and put a 1 there. 1/2 plus 1/3 should be 5/6, right? Here, I'm going to have 3 pi over 3 plus 1 more pi over 3, so I'm going to get 4 pi over 3. Here, I'm going to go over 6, so I'm going to get 9 plus 2, 9, 10, 11. 11 pi over 6. And then here, I am going to have 6 plus 1, which is 7 pi over 3. So each of these should change by the same amount. If I think about this, this is 2 pi over 6, 5 pi over 6, 8 pi over 6, 11 pi over 6, and 14 pi over 6. I made them all over 6, so it's going up by 3 each time, right? So this is now going to be at pi over 3. This one will be at 5 pi over 6. This one will be at 4 pi over 3. This will be 11 pi over 6, and this will be 7 pi over 3. So, 1, 2, 3, 4. Did I not change that graph? Oh, I'm not done. I'm going, that's not going to graph on there, but I haven't finished my problem yet. I only did one step. I added the pi over 3. I still have to do the 2/3 part of it. All right, I only did half my problem. So I need to get rid of my fraction, so now I need to take each of these times 3 over 2. I was going to say it won't fit on my graph right, but I didn't finish, so therefore. So now, let's get rid of those because those were not, whoop, put my pen in the wrong spot. those were not my n numbers yet because I cheated. So now, if we multiply, this is going to give me pi over 2. This one, 3 goes into here 2 times, so I get 5 pi over 4. This one, the 3's cancel out. 2 goes into 4 2 times, so I get 2 pi. This one, 3 goes into here 2 times, so I get 11 pi over 4. And here the 3's cancel out, so I get 7 pi over 2. So, we have pi over 2, 5 pi over 4, and 2 pi. Then we have 11 pi over 4 and 7 pi over 2. So pi over 2, I'm in fourths, 1, 2, 3, 4. Pi over 2 would be here, and it's a cosine curve, so I have to go up to 3/2, which is 1.5. 5 pi over 4, so 4, 5. I'm going to cross at 0. 2 pi is going to go down to negative 1.5. 11 pi over 4, that'd be 8, 9, 10, 11. We'll cross right on the line. And 7 pi over 2 would be 14. 11, 12, 13, 14, going to be up to 1.5. And so my cosine curve is going to look something sort of like that. So I got to do 2 steps on this one if I don't forget to do the second step. Add my number on this one and then multiply by my 3/2, and then I have my new starting values. So this time we're doing the sine curve. Sine curve. Whoops. It doesn't want to erase the board. It wants to do that one over. Sine curve. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since it's a sine curve, 0, 0, 0. And my amplitude and the opposite of my amplitude, which is 5 over 2. So, we are going to figure out our shift, and so we're going to say 3, whoops. Whoop. It's writing a little crazy now. See if that here goes away, if I can erase. All right, so 3/2. See if I erase, if I can get this to work right. All right, try it again. Sine curve, 0, pi over 2, pi, 3 pi over 2, and 2 pi, 0, 0, 0. This will be at negative, or no, this won't be at negative. This will be at positive 5/2, and this will be at negative 5/2. All right, so 3/2 x plus pi over 2 is going to equal 0. So I'm going to, I might as well write them down. 3/2 x plus pi over 2 equals pi over 2. 3/2 x plus pi over 2 equals pi. 3/2 x plus pi over 2 equals 3 pi over 2. And 3/2 x plus pi over 2 equals 2 pi. Let me do both steps at the same time so I don't forget to finish my problem. I am going to go ahead and subtract my pi over 2, which would be negative pi over 2, and multiply by the reciprocal 2/3. So I'm going to get negative pi over 3. This one, I'm going to subtract my pi over 2, which is 0, multiply by my 2/3, which is my reciprocal. I'm going to get 0. Here, I'm going to subtract my pi over 2, which is pi over 2, multiply by my 2/3, so I get pi over 3. This one I'm going to subtract my pi over 2, so I get 2 pi over 2, which is this pi, times my 2/3, so 2 pi over 3. And here I'm going to minus my pi over 2. This would be 4 minus 1, which would be 3 pi over 2. Almost could read that. 3 pi over 2 times 2/3 cancels, I get pi. So, my new answers. Negative pi over 3, 0, positive pi over 3, 2 pi over 3, and pi, which would be 3 pi over 3. So at negative pi over 3, these are over 6, so that would be right here, I'm at 0. At 0, I'm up to 5/2, which would be 2.5. At pi over 3, we'd be back to 0. At 2 pi over 3, which would be 4 pi over 6, I'm down to negative 2.5. And at pi, I'm at 0. And so my curve looks something sort of like that. One more on this paper. Again, we're going to do the cosine curve. And so for cosine, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. For cosine, we're going to go our amplitude, which is 3 at the beginning and the end. Halfway in between, we have a negative 3, and then zeros at pi over 2 and 3 pi over 2. Again, if this was negative, we do the negative first, and then the positive, and then the negative. So we are going to do 2x plus pi equals 0. 2x plus pi equals pi over 2. 2x plus pi equals pi. 2x plus pi equals 3 pi over 2. And 2x plus pi equals 2 pi. And we're going to solve each of those. So we're going to subtract pi, which gives me negative pi. Divide by 2, which is multiplying by 1/2. So negative pi over 2. Here we're going to subtract pi, which is negative pi over 2. Multiply by 1/2. So negative pi over 4. Here we're going to subtract pi, which is 0, multiply by 1/2, which is still 0. Here we're going to subtract pi. So 3 pi over 2 minus 2 pi over 2 would be 2 pi over 2 times 1/2, pi over 4. Here we're going to subtract pi, which is pi times 1/2, so pi over 2. So our new values. We're going to have negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So these are in fourths. 1, 2, 3, 4. So negative pi over 2 would be at a negative 1/2. And then positive 3, because I'm doing the cosine curve, I go up first. Negative pi over 4 is at 0. At 0, we're down to negative 3. At pi over 4, we're at 0. And at 2 pi, or pi over 2, I'm back up at 3. And so my cosine curve looks something sort of like that, all smushed together. All right, so keep in mind that normally, if this is positive, you go up first. If it's negative, you go down first on your amplitude and the opposite of your amplitude.